guys, Tori here from Overlook Horizon. We're coming to you live today on Tuesday afternoon. Merry Christmas, Happy Holidays, Happy New Year's to everybody. We're not quite at New Year's yet, but we're getting there. But wanted to throw out a little live video here. Hopefully everybody can hear me all right. Got a little bit of a different setup for today, but one of the most common questions we get sent to us by email, by Twitter and everything is about Arduino radio tracking system using APRS. So I want to give you kind of a quick and dirty method to get up and running real fast here, kind of show you what we're looking at. So we're going to do it live. Got a new internet connection, so it got upgraded. So hopefully this is going to work. Usually from home, I can't do Facebook and YouTube at the same time. Today I am. I got to sit back a little bit. I got a light right in front of me, and it looks like it's washing my face out. But we're going to try to do this. Live, and hopefully it's not terrible quality. Looks to be okay at the moment, other than the fact that I look white as a ghost. Might have to change that at some points, but in any case, let's see here. Make sure, first thing I want to do is make sure all my streams are up and running here. So I got Facebook running. That looks to be okay. If you're here watching, send me a little message. Let me know that the stream's all right, just so I can make sure that everything is up and running there. Also, if you're on YouTube watching as well, shoot me a little message on the live chat there, and we'll make sure everything is up and running. Also want to give it a few minutes here so that people can join in and check out the live video. So, one of the things that a lot of people want to know, like I said, is about the APRS radio tracking systems. And there's a number of different ways you can go. You can buy a pre-built system. There's something called the Eagle computer that is sold by High Altitude Science. That's kind of a pre-built system. You can buy GPS trackers that are more like the Spot 3 tracker to put on your weather balloon as well. The downside of the GPS trackers is that they usually only work up to about 60,000 feet, and then they're going to stop. And then on the way down, they theoretically should pick up again, but it's the GPS tracker has to always be facing up to get a solid signal. So there's been a lot of payloads that get lost when the GPS tracker, one of those Spot 3 trackers, comes down, lands, it rolls over on its side or upside down or underneath cover, or maybe on the side of a building, and it just can't get GPS signal, and it never reports its final position. Also on the way down, a lot of times the package gets jostled around quite a bit, so it may not even get signal on the way down, and it may be just relying on coming to a solid rest on the ground to actually get a signal. I mean, don't get me wrong, those GPS systems are fantastic as a backup method, and a lot of people use them as a primary method, but personally, I love the radio tracking method the best because you can get much more frequent updates that during the flight and throughout the entire flight. So a GPS system, a radio tracking system, if it's built with Arduino or Raspberry Pi, you can track it all the way up to, I think the theoretical limit's like 160,000 feet, but no weather balloon that I know of has ever made it that far. I think the highest one that I know of is about 140,000 feet or somewhere around there. So for the average person that's going to run a weather balloon flight that may get to 100,000, 120,000 maybe. I mean, you can safely use a radio tracking system with Arduino or Raspberry Pi and track the thing the entire way with, roughly 60-second transmission intervals. And so you get positioning data every 60 seconds. I mean, you can change that to your liking. We can talk some about the APRS radio network a little bit, because there are some common courtesy things that you want to do if you're going to be broadcasting, so they don't completely monopolize the network, because it isn't just between you and the balloon. If you're using APRS, you're using that frequency, which other people rely on it being open at least sometimes. So you want to be a little bit courteous in your broadcasts and not be completely monopolizing it, but usually about 60-second transmissions is going to be acceptable. So today, like I said, we're going to look at the Arduino-based systems. You can build them with Raspberry Pi as well. I've used Raspberry Pi. I've used Arduino. I love both systems. For me personally, the way I look at the two different systems, Arduino to me seems much cleaner. It's a microcontroller, so it's very stripped down. By default, it's not going to have anything like Wi-Fi or network connections or anything. It's just going to be a looped program that runs over and over again. The Raspberry Pi is definitely great for building network connected applications and web servers or little mini computers, things like that. So we use, a lot of times what we use is Raspberry Pi for the ground-based station, receiving the signals and putting them onto the APRS network using an iGate, and we use the Arduino-based systems for the actual transmitter just to strip it down, get rid of some of that extra stuff that comes with just a Linux operating system, and we can strictly worry about just the code that's on the Arduino system. So we're going to look at Arduino today for our tracking systems, because that's what we use when we fly our weather balloon flights. And we're not going to go too far into it. It's not going to be too detailed as far as any of the software theory stuff. But what I wanted to get is, we get a lot of young students that are looking to get started, and they're just like, I don't even know where to start. Like, how do I get a system up and running that will work on Arduino, just so they have a platform, a base that they can build off of and then get into it. So that's kind of what we're looking at, is just that base building block today, and how can we get up and running. So what we're looking at, we're going to use an Arduino. I've got two Arduinos here. We've got my Arduino Mega. That's what we use, and that's what we fly with. But I'm going to start with an Arduino Uno. I've already got it connected here, so I don't want to disconnect it, but I'll hold it up. There's our Arduino Uno. And actually, I even got a camera shot for this, so I don't even have to hold it up. But here, let's switch over to this, just so you can see what's going on. So this is our Arduino Uno that's already wired up and connected, and I'm going to switch that out for the Mega a little bit later here. But basically, the reason for the Uno is because we're going to use a software library called FlexTrack, which is the library that we started with when we started building these systems, and then we've kind of morphed it since then. But the FlexTrack system is, or the library is open source. It's written really well and will get you up and running. It's designed for Arduino Uno. So it's easiest for me to show you on the Arduino Uno, and then we can move it to Arduino Mega if you wanted to use that. So the reason we use the Mega is just because it has a lot more pins that we can connect additional sensors to. So we've got cameras that we control on board. We've got humidity sensors, temperature sensors, pressure sensors. We've got our GPS systems. We've got some alarms that are built into it, a landing alarm, what we call the anomaly alarm, which generally shouldn't go off, but it goes off way more often than it should. That usually means there's a problem. So we've got a bunch of things that we like to connect to it. It also has some more onboard memory as well for the program itself. So ours gets our program and our peripherals get pretty beefy and start to add up quickly. So we switched to the Mega just for that reason. But like I said, we're going to start with the Uno here. So if you're going to build your own Arduino-based tracking system, and it's going to be radio-based, the first thing I would say is if you're going to do it, in the United States, you have to have an amateur radio license or ham radio license. It's really easy to get, and that's a little bit of a hurdle for a lot of people. They're like, I don't want to do the test, or because you have to take a test and you got to get licensed. It's super easy. You can get an app for your phone or your iPad and take a couple practice tests. A lot of it is pretty common sense stuff and pretty basic. Some of it gets into like antenna theory, and some of that you may have to study, but it was pretty easy to take that test. I thought it didn't take a ton of studying. I'm not somebody that loves to study, so it took just minimal effort for me to learn some of the stuff, the radio application stuff, because that's not my forte, the radio theory or antenna theory or any of that. But you got to get an FCC license for amateur radio or ham radio, And that I recommend getting it anyways because it opens you up to a whole bunch of other things that you can do with amateur radio. And it's not just getting on the phone, getting on the radio and talking with people around you. I mean, that's great, and you can get involved in your local amateur radio community, but you can also do some pretty cool things with the technology, with building weather balloons or building computer systems that communicate by radio signal, or even receiving radio signals from people far away, or transmitting radio signals to people far away, which gets, those are some pretty cool things, I think. So anyways, definitely take the FCC test to get amateur radio licensed. In the United States, you only need a technician's license, which is the lowest level license you can get. You take the test. It takes, after you do your study and you go to one of these test sites, which are all over the country. Ours was 5 minutes from my house here. You go take the test. It takes about an hour to go take the test, get your results, get your license, and 2 days later, you're ready to go. So you got to start with getting your amateur radio license, because if you're going to do this, that's going to be required. And then the next thing you're going to do is check out the FlexTrack library. So if you're watching on YouTube, I put a link in the description below right to the FlexTrack library. If you're watching on Facebook, if you just go to Google and Google FlexTrack on GitHub, that will take you right there. You can also get links to that on our website too at overlookhorizon.com, because we've put links there as well to get to the FlexTrack library. But that's the one that we start with. There's a lot of others. There's Arduino. The FlexTrack library is actually kind of supersedes the Arduino library. So I would go right to FlexTrack if you're looking into that. There's also Arduino, and there's a whole bunch of them out there. But we use FlexTrack. It's the easiest one to use that we've come across. And so basically, I've already downloaded it, and I've got it open here. So this is the FlexTrack library, downloaded right from GitHub. It has no changes to it whatsoever. So out of the box, it's almost ready to work. I mean, there's really minimal changes that you have to make if you're going to run it on your own Arduino. So it's pretty quick and easy. I mean, we're going to look at some of these, and code-wise, what it's doing here is that this library is designed to work with a number of different systems. So, the first section here is basically telling the software that we're going to use Arduino, which Arduino is pretty close to what we want. We don't have an actual Arduino board, so the Arduino is like an actual pre-packaged board that you can buy, which you're certainly welcome to do. You could literally get the Arduino board, the FlexTrack library, and you're ready to go. No changes necessary. But if you want to build something on your own, just a few minimal changes. So what we're going to do, and what we're going to start off with, is let's see, is this even readable? It's not too bad. I guess it's a little bit blurry. I could probably, let me see. I want to see if I can zoom. Oop, not that. I just want to see if I can zoom in for you. Not that. Let's see, one of these things. There we go. I want to zoom in on this guy. Oh, that doesn't help me. How do I zoom? I got this nice fancy broadcast software, and I don't know how to zoom on it. How do I zoom in on my screen capture? All right. Well, I guess that's a question for another day, because I don't know how to zoom. I don't know how to easily zoom in on this so that you can see this better. But it looks like you're gonna have to go like full screen. Now, hopefully, you're not watching on a mobile phone. If you're watching on a mobile phone, it might be hard to read this. But we'll talk through it. So you may have to watch it on a desktop at some point if you want to actually see the details here. But so first thing we're going to do, we're just going to comment out the Arduino part. And like I said, this is quick and easy. So you can keep a lot of this stuff that we're going to get rid of, but we're going to keep it very simple. And really all I want is, if we look at the actual tracking system that I have set up, we can look at the components here too. So we've got the actual, this is the Arduino Uno here that's already wired up. We have a Radiometrics radio transmitter. This is also a link in the description below on YouTube on where you can purchase that. You got to buy them from the UK. They're the only manufacturer, but this is ready to go. It's on 144.390 megahertz, which is the APRS frequency in the United States. So this guy is pretty much ready to go for APRS right out of the box. So we've got the Arduino, the radio transmitter, then this is our GPS chip and our GPS antenna. And that's it. That's all we're going to do. You can add temperature sensors, humidity sensors, pressure sensors, and all kinds of other stuff to your system. But we're just going to do the Arduino, the radio transmitter, and the GPS, and that's it. Simple, up and running, real easy. So anyways, back to let's go back to the software side of things. So we're getting rid of the Arduino definition up here. We don't need that. There's some settings for RTTY if you're going to use that, but we're not going to. We're going to comment all that out. There's some power save settings for GPS. We're going to comment that out. We don't need that right now. There's some other LoRa settings here. We're going to comment those out. We don't need those. And then we get down to APRS settings. So the first thing you would need to do is you got to put in your call sign, your FCC call sign that you got assigned after you took the amateur radio test. We're going to keep that. So there's my call sign. The SSID, usually for weather balloons, you're going to be 11. You can use pretty much whatever SSID that you want. It's just an ID number attached to your call sign. So you could have multiple. You could potentially have, if you put two balloons up, one could be SSID 11, another one could be SSID 12, or if you put two radio tracking systems on the same balloon, one would be 11, one would be 12. Usually the standard is 11 for weather balloons. So I wouldn't mess with any of that. And then a lot of these settings we're going to leave alone. The APRS path altitude determines when the APRS path changes, at what altitude in meters. We're going to leave that alone. We're going to leave when Y2 is used alone. The transmission interval, this is every 1 minute transmit interval. We're going to leave on pre-emphasis. We're going to leave the random setting at 30, so everything here is all staying the same. APRS comment, you could leave it. This is Dave Ackerman's website. Definitely check out his website. He's the guy that wrote this FlexTrack library. He's a great resource. He's like the high altitude weather balloon expert as far as I'm concerned. So, but usually you change this to be something, something about your project. So, we'll just throw in our website here. And then there's a telemetry interval. We're going to leave all that alone. And then these are all the definitions for basically how your board is wired. How are all these components connected to each other? So there's some boards up here. We don't use any of these. We're going to be closest to Arduino. So we're going to take all this stuff. We're just going to comment it out. You could just delete it because you don't need it. We're going to go down to the Arduino section, and I'm going to actually get rid of the Arduino definition. So we comment out these if statements just to simplify here. We don't have a warning LED, so we'll comment that out. We don't have an external OK LED. That just means all systems are go, but we're going to use the LED built right on the Arduino board, which is on pin 13. So we'll leave that alone. GPS on, that's like an enable for GPS. Our GPS chip doesn't have an enable, so we're just going to comment that out. We don't need it. RTTY, enable, data, PWM, we don't need any of those. We'll comment those out. APRS enable. All right, now we're getting into stuff that we actually care about. So APRS enable is on pin 6. This is the pin. It's just on or off for your radio transmitter, when you're going to turn your radio transmitter on and when you're going to turn it off. It doesn't control the actual data sent for it. It's basically like the push to talk. If you're thinking of like a walkie-talkie or handheld radio, this is the button on the side to turn on the radio and turn off the radio. So that's like your push to talk or PTT button. So that's going to be on pin 6. APRS data, this is actually what we're sending through the microphone or through the radio transmitter. So that's going to be on pin 3. A0 multiplier, this is for measuring voltage. We don't, on our quick and easy setup right now, we're not going to measure any voltage, so we're just going to switch it to 0. Wire bus, we can leave that alone. Wire bus is for temperature sensors, so you can get a whole bunch of temperature sensors, put them all on one wire bus using the one wire library. We are not going to mess with that at all, so we'll just leave it alone at 5. And define MTX2, we're going to comment that out because we're not using that as well. And then here's another definition here, and we'll comment that whole thing out there. So that's pretty much it. So I know I talked there for a while, but really all we did was we set our call sign, we changed the comment, which you don't even really have to do, but call sign, comment, and then we commented out a whole bunch of extra stuff down here that we don't need. But basically, the super important things are going to be that the APRS enables on pin 6, the data's on pin 3, so that's controlling our radio transmitter. And then a little bit further down, it already specifies this, but the GPS is going to run on the serial port. So on Arduino Uno, the base serial is pins 0 and 1. So we're pretty much ready software-wise. But let's take a look at the board itself. All right, so let's see. Let me spin this around. Put the Arduino. Let's see, which way do I got to move? There we go. Put the Arduino in camera view here. So this is our 5-volt power here. That's just going to run to the breadboard's 5-volt. And I'll put a link in our YouTube video that'll go right to a schematic diagram for this. So if you're having a hard time following my spaghetti here, I'll put a link to a legit schematic diagram online. But anyway, so let's see. Hold on, bear with me. Let me just make sure. I haven't really looked too much at comments. Let's see what we got. Angelo, looks good. Thanks, Angelo. Appreciate it. Basile, use a Nikon P900. All right, I'm assuming he's talking about cameras. One of the big things that we always get comments on is our cameras. But, yeah, we'll definitely take a look at that. Morris Messing. Hey, Tori, how are you? Hey, Morris. Good to hear from you. It's been a while. So let's see. Oh, I lost my comments for my YouTube feed. Let's go back to, where's my YouTube feed? Bear with me 1 second. I gotta get the YouTube feed back up here. Hopefully it's still running. I thought I had it open here, but just going to town. Andrew Murphy. All right, sounds good. All right, yeah, looks like it's still running here, so we are in good shape. All right. So, all right, so let's go back to the Arduino here. So we got our power. That's the red wire here. So anywhere you see the red, those are our power. So we got a power from the Arduino to our power rail on our breadboard. We got a power from the power rail to the radio transmitter. We've got a power from the power rail to the GPS system. And then white is our ground. So we've got a ground going to the ground rail on the breadboard, ground going to the radio transmitter, and a ground going to the GPS. So that eliminates a lot of the spaghetti here that you're seeing. But then the other areas for wires here, we've got the orange wire here is our pin 6, and pin 6 is our enable. That's that push to talk button to actually turn the radio transmitter on. So that's pin 6 getting wired up to the radio transmitter here. Pin 3, that's this big long yellow one, that's our actual data that we're sending. That's going to have our transmission data that's going to the radio transmitter. And then pins 0 and 1, that is our serial bus for the GPS system. So we've got the yellow wire it's the transmit from the Arduino board to the receive on the GPS. and the green is the receive on the Arduino to the transmit on the GPS. So it's a little bit confusing when it comes to GPS systems because you're connecting opposites there. So the receive, say it again, receive on the Arduino goes to transmit on the GPS, because the GPS is going to transmit and the Arduino is going to receive it. And then the Arduino's transmit is going to go to the GPS receive. So if the Arduino is transmitting data, then the GPS is going to receive it. So it's a little bit backwards. If you're new to wiring up circuits like that, usually you'd see, receive, you'd connect receive and transmit and transmit. You're not doing that here. Receive goes to transmit and transmit goes to receive, so you're connecting opposites there. So that's pretty much it. We got, let's see, 1, 2, 3, 4, 5, 6 wires here that are connecting and running our Arduino Uno. And we'll be ready to transmit here. So let me get you back to here. Let's see. Let's give this a shot and see. We'll hook this up here. See if we can actually transmit something. So we're going to actually write this to the board, see if I did it right. Compiling, uploading. Oh, it's not uploading. Okay, here's an important thing. I always forget this. Let me go back to the wire here. So one important thing, if you're using the GPS on the serial, the programming for the Arduino also happens on the serial bus. So you can run into a lot of conflicts there. So I usually unhook our GPS serial here, and then we'll try to program it again. And then it should hopefully work. Let's give this a shot. Compiling, uploading. There we go. Now it's uploading. Done uploading. Okay, see, that worked. So now we're powered up. Now we can plug the GPS back in. All right, and so our program's running. Now let's see if I can't crush my computer's resources here. We're gonna try to open up our SDR, software-defined radio, and our direwolf, which should be able to decode this signal here if we can do it right. So let's see. Let me get this up and running here. Yeah, fantastic. All right. Let me move this over to a screen you can see. So here's SDR sharp. That's generally what we use for receiving our radio signals. So I've just got an antenna. Whoop. Let's go back here. Where'd my direwolf go? There it is. There we go. Let's move this over here and set this in the corner. So we use SDR sharp and direwolf. SDR sharp is actually receiving the radio signal, and then direwolf is going to decode it. I'm just going to hit the reset button on the Arduino just so we get back to it. And there's the transmission. And we didn't get any, because it's trying to use the webcam as the audio source. We don't want that. So one of the things, we get a little mini tutorial on direwolf here. Let me just switch this up. So usually by default it just goes right to what I want. But since I got an extra webcam in for this broadcast, it doesn't. So what you can, let me get this moved over here to the other screen so you can actually see what's going on. In case you want to see that for direwolf. So here we are. This is our direwolf configuration file. Really what we're going to try to change here is we had set up a virtual cable. It's a bit of a process to set up direwolf. We'll do another video on that. But basically what I'm going to change is I want the audio input to be this number 2, the cable output. So we're going to come down here and we want to change a device to 2 and 0. Save that. And then we should be able to restart direwolf. All right, now we're in better shape. Make that a little smaller. All right, hit the reset button on my Arduino, and we should get a radio transmission here. Let's see what we get. Possibly. Did it reset? All right then. Let's see. Reset. And we'll see if it runs. Well, of course, now it doesn't work. What did we break? It was working all right. Cable output, is this going to, yeah, so this is going to cable input. That's going to cable output. I don't know the answer to that. Well, seemed to have been working a moment ago. Oh, see, there it is. Ah, all right, so there's our data. So there we go. So there's our data getting decoded. You can see the call sign here listed. We've got a position of 0, 0. So the way the flex track is set up is it's going to transmit right away before it even gets GPS signal. So our next transmission, if we wait just a minute here, so we're transmitting on roughly 1 minute intervals, we should get another transmission here in roughly a minute that will have actual GPS signals in it. So leave this up here for just a moment, and then we're going to switch back and we'll do the Arduino Mega after this, and I'll show you how what we have to change for the Arduino Mega. It's not much. There's not much that has to get changed, but you do have to change some stuff, and that can trip some people up as well. So I just want to wait and see if we get another transmission here. While I'm waiting, oh, there's our transmission, and there's our GPS position. So we're in good shape. So that all worked out, and everything's working there on the radio signal. And so, oh, I should have left that open because I'm going to show you the Mega now. So let's switch this out, and we're going to go and do an Arduino Mega now. So we'll get rid of the Uno. We don't need this here anymore. And we're going to bring in our Arduino Mega. So we still need, I mean, the basics here. We're going to need power, and we're going to need ground. So we'll get those hooked up right away. And then the others is where we're going to get a little bit different. So for us, we're going to use the data, the APRS data, which was on pin 3, is now going to be on pin 9. So the Arduino Mega has different pins for the same timer. So this is timer 2 on the Arduino Uno and Mega. It's timer 2, but timer 2 on the Uno is on pin 3. Timer 2 on the Mega is on pin 9. So we're going to move that to 9. Our enable, I'm actually going to move the enable over here to the analog pins. I like to use analog 3. That's just happens to be what our systems use, is we use analog 3 as a digital on-off pin. And then that leaves our GPS. One of the nice things, so we ran into that problem trying to write the program to the Uno because the GPS was conflicting there. One of the nice things is the Arduino Mega has multiple serials. So we're going to use serial 3. And let's see, which one's which here? This is, the green is the transmit, so that's going to go to receive on the Arduino. And the yellow is the receive on the GPS, so that's going to go to transmit. So we're going to use serial 3 on the Arduino Mega. So that's our same wired up connection here. Now we'll go back over to the software, and here's what we got to change. So we're back on the configuration page here. We need to go back to our settings here where we were talking about LEDs. The LED can stay the same. Our enable, we changed to A3. Our data is now on pin 9. The rest, all that stuff we can leave alone. And then we just need to change the GPS serial to serial 3. And then we're also going to go up to the tools menu here, and we're going to say that we're using an Arduino Mega now. And so I don't have it plugged in yet, so I don't have a port. So let's plug it in and get a port. Oh, no port yet. There it is. COM8 is our port. So we should be good. Let's give this a try. I didn't test this beforehand, so we'll see if this works. So we're compiling, and we're going to upload this to the board. It's uploading. And we're going to need our SDR sharp again to receive the radio signal. And our dire wolf. And let's see. Get this up and running, and we'll zoom this in. Let's hit the reset button. See if this will broadcast the signal. It should be all we have to change, I believe. We'll see if this will run here. So I'm getting no signal here. Let me move this out of the way. While we're waiting to see if that signal comes through, let me just make sure that I didn't miss anything. Oh, one of the other benefits that we can do as well is now that our serial is opened up, we can actually do some debug as well. Let's see, so we can pull up the debug console. Let's see if it's even running. Oh, we're getting stuck setting flight mode. Oh, maybe it's still trying to, it looks like it's still trying to use the GPS on the regular serial. So here, let's go back to our software. Let's just make sure. I'm going to copy this, and we're going to put this up here. We'll define the GPS serial as serial 3, and then I'm also going to change the debug serial to 15200. Let's see, where was that? 115200. Oh, not 220, 200. And let's try to write that. Let's see if that helps us out. Oh, looks like it's still trying to write to the regular serial. Where is that happening? Let's see here. Should be on serial 3, right? That seems right. Serial 3, debug is regular serial. Are we, oh, let me stop the auto scroll here, go back up to the top. Serial GPS, APRS enabled. We have no DS18B20s, those are the temperature sensors. Keeps just trying to set flight mode. Let's see, let me find flight mode here. Setting flight mode. That's doing serial.print, setting flight mode. Let's see. So flight mode, while I'm looking for this, flight mode is very important. Something that you definitely want to set, and a lot of people miss this when they're building their own systems. Flight mode is what tells the GPS system that you're going to actually be flying with this thing. So by default, most of these GPS chips come in pedestrian mode, which the system is not expecting. Oh yeah, here. So here's a bug in this software. This is not supposed to be serial.write. It's supposed to be GPS serial.write. All right, so one other thing you got to change, it looks like. So this is in the GPS tab here. There's a send UBX function. in this for loop, make sure you change that. This was serial.write. We don't want serial.write. We want the GPS serial. So let's try that. That should help us out a little bit. Actually, all of these, looks like there's a whole bunch of references here. These should all really be GPS serial. Well, we'll see if that, yeah, so it's getting stuck setting flight mode over and over and over again. Let's see, so where do we set the, let's see, so now we're going to do some troubleshooting. Where do we set the flight mode? We set flight mode there, and then we switch pole mode. Well, required flight mode does not equal GPS flight mode. Well, now see, it's been so long since I've done this. Our system uses we've got our own whole custom GPS setup here. So, send UBN, yeah, that's all fine and dandy. Well, just getting stuck on that. Well, what you could do, because we could fix that, because we don't have to use serial 3 if we want to get back to our quick and dirty method here of handling this. Let's go back and just use the regular serial so that we can at least get a proof of concept here that it works on Arduino Mega. So we're going to change our here we go. We're going to change our wiring to, we're going to go back to the regular serial 0. So we want transmit 0, let's see, transmit here is going to go to receive 0, and receive on the GPS is going to go to transmit 0. Let's try it that way. Oh, blurry, hello. Let's see, which way do I get them? There we go. So, here, let me see, can I move this cord? Oh, I can't move it. The camera's in the way. Just so you can kind of see what's going on here. So we'll just go back to using the regular serial port here. And now let's see if we can write it. Actually, we'll have to disconnect this for a moment. Let it actually upload to the board. Once it's done uploading, then we can connect our GPS back to the board. Like that. There we go. Let's see if that'll work. See, the downside to this, though, is that we can't debug while it's happening. So we want to see if we can get this guy to transmit now. I'm seeing no transmissions. Wow, that's a shame. We can also well, that's unfortunate, because now we can't see. Well, we could try to debug and see what's coming out here. Oh, that might be what, since we changed that, let me change this back. So we changed the baud rate for the debug to be something different than the GPS. So we got to change that back because we're using the same serial baud rate, or same serial bus for both the GPS and the USB programming plug here. So let me try to upload this again. All right. There we go. That's done uploading. Oh, there we go. There's our signal. That's the problem. So there we go. Now we got a signal on the Arduino Mega. So we did a whole bunch of stuff there. Let's recap so that we can at least see if somebody was trying to follow along with that mess. So when we moved to the Arduino Mega, we changed a couple of things. And they're really just in this configuration setting. We changed APRS enable to go to A3. That's this orange wire here. That's going from A3 right to the enable pin on the radio transmitter. We changed the APRS data to pin 9. So that's one of the real important things here, is that since it's using timer 2, we had to move it from pin 3 on the Uno to pin 9 on the Mega. And then we tried to use a different serial bus, but that didn't work out. So we're just using regular GPS serial is going to be on just regular serial. And you can ignore this. We don't need that. We can just delete that. So really, it was just 2 changes that we had to make. We made it even simpler in the end. We changed the enable to A3 and the data to pin 9, and now we're operating on Arduino Mega. So personally, I would not be satisfied with it. This will fly like this, but one of the things I don't like about it is that it's running on the serial 0, which is what the USB cable uses to program the Arduino board. So I don't like that. It bothers me because it conflicts, and you got to unplug the GPS to upload new software to your board, and then plug the GPS back in so they don't conflict. So I don't like that very much, but I don't want to go through reprogramming it. So in our, we started with this flex track as our base, and with our software we went through, and ours uses serial 3. So I'd recommend looking through the GPS tab in the flex track, and you'd want to go through and edit some of these serial commands, because it looks like they're just using the default serial. Sorry, I'm laughing because I said serial, and my iPad over in the corner goes ding ding. Siri thinks I'm talking to her. So in any case, you may want to go back through and look at those GPS tabs to see if you want to change that to use serial 3. It'll work on serial 0. It leaves me unsatisfied, and it bothers me. So you can certainly change that out, and we can certainly do other videos on how to change that out, or what you may need to change, as well as adding sensors and all that kind of stuff as well. But we've been going here for do I have a timer somewhere? An hour. We've been going for about an hour here, so I don't want to make this too crazy long, because who's going to watch if it's crazy long? But I wanted to get it up and running so that you could at least see that we've got the tracking system running on an Arduino Mega, just with a couple of simple changes from the FlexTrack library. And basically now we have a system that could potentially fly. I mean, it's not pretty, but this is a system that could potentially fly. I mean, if you take these wires, this is not unlike our first system that flew. I mean, you take some of these wires, you may want to secure them with a little bit of electrical tape or something. If you want something crude, you could make this work. I wouldn't use these flimsy jumper wires. I'd use something a little more rigid. I've just got a box of I think this is 22 gauge solid wire that we use. We used to use. We don't use it that much anymore, but we used to use on one of our first systems. And I can even we've got, let's see, I don't have to yell. I got a microphone on. I was starting to yell like you guys couldn't hear me, but I don't know if we've still got our original boards here from our first flights that really looked kind of crazy, because our new boards now are pretty clean and refined. I don't see, I think I dismantled a lot of them because they were just such a disaster. But you can see there's we've got this, let's see, can you see this? There's like a proto board here. And this was kind of like one of the very first things that we did is we got these, let's see, I'm going to unplug this here now, get all this stuff undone. So we got ourselves an Arduino Mega, and then we got a Mega proto board. You can even get an Arduino Uno proto board. One of the first ones we did was an Arduino Uno proto board that we plugged into the Arduino Mega. And a proto board really is nothing more than just a board that's got a whole bunch of through holes popped through it that you can solder together. And it doesn't come out pretty, but it works. So, you know, you can see on the front we've got some wires soldered on there. There's a resistor and an LED. And this was this was one of our first boards that flew one of our weather balloon flights. So so you take that mess of wires that we were looking at. I guess I could have made this video bigger, because you take this mess of wires here and you make these all soldered connections on a proto board, and you could fly with that, because that's not unreasonable. You could fly. You know, we've got, what have we got here? Like, well, let's see. I'm going to pop off this GPS antenna just because it's dangling here. It's not connected to anything. So just pop this off here. But this is basically all the components you need plus the Arduino. And if you don't want if you want to go even smaller and simple, just use the Uno. Get a Uno proto board, and you can get your radio transmitter and your GPS. And there's a tracking system right there. There's no sensors on it. You can add those later if you want, but that will get you up and flying. And we've got, you know, what do we got? 1, 2, 3, 4, 5, 6, 7, 8 wires. 8 wires plus these 2 that go to our main power and ground. So 8 or 10 wires here, and you can get yourself up and running with a radio tracking system. So, but like I said at the beginning, the big thing is you got to get your ham radio or amateur radio license. That's the big roadblock. And then if you're going to order one of these radiometrics things, now that I'm done with this, I can start taking it apart. But this is what it comes like. It's pretty small. Let's see, can you see that? Will it focus on that? I don't know if it'll focus. It's just going to get blurry. Well, let's see. Let me hold it right there. That's what it looks like. It's not very big, but that's the radio transmitter there. You have to get those. We order them from the UK, from a store called Uputronics. They're very reasonable, very responsive. Guy's a high altitude balloon enthusiast, so they send them right over. It takes about a week to get to the States. That's on the East Coast. If you're on the, I don't know, if you're on the West Coast, you may be allowed for a few more days. And then our, let's see if I can get this out here. Now I'm taking apart all my stuff. Our GPS is just from Amazon. So there's a link on our website and in the YouTube video. This is the GPS chip. Will it focus? No, of course not. But this is a GPS chip. Usually they come with this is a passive antenna. You can get one of these for about $10 on Amazon. And we've got links on our website and in the description of the YouTube video for where you can get those GPS chips on Amazon. So they're on Amazon. Everything's on Amazon, but not the radio transmitter. And then obviously you can get Arduino Uno on Amazon. You can get Arduino Mega on Amazon. The big thing is if you're going to get one of the Arduinos, just make sure they're not counterfeit, especially if you're going to do some high altitude ballooning. There's a lot of lookalikes that are not genuine Arduinos. So a genuine Arduino is going to have this green colored board always. If you got a black board or a blue board, I got one of them here somewhere. Let's see. Yeah, there's one. Let me just take this apart so you can see this. So here's two Arduino Megas. Let's see, which way do I gotta move? One's a counterfeit, one's genuine. The Arduino Mega board is always a green color. So this one is a counterfeit. See how it's, I don't know how well you can tell that, but this is a pretty royal blue color. This one is that green color. This is the genuine Arduino. This is the fake counterfeit Arduino. You can also tell on Arduino's website they have some guides on how to tell that as well, but you can tell it with the logos too. It's going to be hard to see this as well, but this, let's see, which one's the counterfeit? So here's the counterfeit. This logo here has got a bunch of dots and it says Mega, and even inside the Arduino logo there's the plus and minus in there. If you look carefully at this, the plus and the minus are off-center. It's not real solid quality. The Mega is a little bit pixelated. If you look at the genuine Arduino board, the plus and the minus are dead center always. And the Mega is never pixelated or anything like that. So if you see anything that's pixelated or it's not dead center on the logo, then it's not a real board. So it's a counterfeit. So just if you're going to get an Arduino, there are Arduino based boards. Those are okay. No problem there for manufacturers that want to make those. But the ones that are making boards that say Arduino Mega, and the reason we have this, we got fooled into it on Amazon and we just thought it was an interesting teaching point, so we didn't send it back. But this, they come across and they advertise that they're an Arduino and they're not. So they're not contributing to the Arduino open source project. So if you're going to actually get a genuine Arduino, make sure it's not counterfeit. So anyways, there we go. I kind of rambled on for quite a while. Let's see, volume is low, can't hear, volume is low. Oh, sorry. Can we, can always bump that up if I need to. Yep. So, of course, it's the end of the video, so it doesn't help now. But anyways, just wanted to get something out there so when people ask on building those APRS systems, we had something to show for it. So that's what we've got. Wanted to take a look at the Uno, the Mega. I think we successfully went through both of those. So anyways, as always, you can check out the website at overlookhorizon.com. If you got any questions, shoot us an email. Let us know. We'll be happy to help out with any of your projects you have going on and give you advice or let you know what we've done in the past. And then definitely subscribe to the YouTube channel or follow us on Facebook because we've got our flights coming up in the spring, probably around March or April time frame, somewhere in there. Don't have a firm date yet, but that's the plan right now. It's probably March or April will be our next flight. So yeah, anyways, thanks for checking out the video today. Appreciate you watching, following along. If you're watching sometime in the future, thanks for watching again, and we'll see you guys all in the next video. Thanks, guys. Have a good day.